Hi there, this is Jacob Nash, Algebra Lessons, and this is Unit 7, Lesson 5 on transformations of exponential functions. So, we've seen transformations with lots of different functions. We learned about all the parent functions at the beginning of these lessons, and we've had transformations for those, but what does it look like for this? So, let me think. We've done transformations of quadratics, we've done transformations of rational and radical functions, and now we have of exponential functions. So, remember the parent function is this. So, remember parent just means original. That is this. Okay. I don't know why this seems smaller than usual. Okay, this is the parent function. So we can see that right here, this thing I have written, this might look weird, but these are just things that can change. The A, B, K, and H. Those are things that can change, and when those things change, transformations happen. So obviously X, that's just a variable, so that's why that is. The A is typically 2 for the parent function. And then we have plus or minus because those can be plus or minus. So let's see what things there can be. So first, A equals 2. That's the first thing we have. If A equals 2, what happens? It's the normal parent function. We can see we have a 2 here. That's what it's like. So, and it means that you would have to multiply y values by 2. Now, that's kind of already done looking at the last lesson. So, when you have these values here, the y values, they're already being multiplied by 2. That's already something that there is. If they weren't, then it's kind of hard to explain. But basically, the values are already like that, so you don't necessarily have to multiply it by 2. If you didn't, then it would just be a function that's linear. So that's why that's like that. So if A is greater than 1, which is the case for the parent function, then there's a vertical stretch of A. So basically, whatever A is what a vertical stretch is. So there's automatically a vertical stretch anyways with the parent function. So in some terms, you could really say exponential functions are a vertical stretched version of a linear function, if you want to say it that way. If A is between 0 and 1, you might think vertical compression. Actually, that's different this time. Instead, it's a decay. Growth and decay. So growth is this, like the original, where it increases. But decay is where it's like, oh, well, fine, I'll decrease. So that's what the difference is. And then we have, if A is negative, that means a reflection over the x-axis. So this is the x-axis. So instead of being like this, it's like this. Okay? So then we have B. So those are the things for A. What about B? So B is up here in the exponent. If something's multiplied right beside the x, a coefficient of x. Now these things we're not going to talk about too much because that's mostly pre-calculus things, but I will briefly mention it now. If B is not 1, and in this case you can see B is 1. So if B is not 1, then that's when there's a vertical compression of B. So instead of being like, by the way, a vertical stretch, the more that it is, the more rapidly they'll go up. It will be mostly more gradual if it was a compression. So then, what if there is negative B? That means a reflection over the y-axis, actually. So instead of this, it's like this, which kind of looks like a decay also. So, but we're not going to talk about that too much. Okay, so what about h and k? Well, h and k are just like it was for other functions. If you have positive h, it's left. So that's something, remember, that's kind kind of seems confusing. You usually think positive right. Once again, it's because if you were to set this equal to 0, then h would be negative anyways. That's why it's like that. But you can just remember that positive means left h units. So if h was 7 and it was negative or plus 7, it would mean left 7 units. And what you do is you do x minus h, whatever it is. And if you have negative h, you go right h units and you add whatever h is to x to make the transformation. If you have k, positive k, that means up k units. And the important thing for k, when k is not just 0, which it's 0 in this case, really, if you could change this parent function so it makes more sense to what we're doing, we have this. We have a that's 2, b is 1, and k and h are 0. So that's what that's like. That's just a normal thing. But the vertical asymptote moves. So if you, we'll see what this looks like in a minute, but whatever that k value is, that becomes the horizontal asymptote. So vertical. Wait, vertical asymptote. Oh, wait. Well, if we're, I'm getting confused here. What I'm trying to say is whatever k is what the asymptote becomes. So y equals k. So if k was 3, then the asymptote would be y equals 3. So it would be right here. So that's what it is, okay? And it doesn't matter if it's positive or negative. Oh, yeah, I'm sorry. This is supposed to be vertical or horizontal asymptote. That's why I was getting confused. This is a horizontal. If it's like that, it's horizontal. I don't know what I was thinking when I did that. Did I say that on the other lesson too? Let me see. Yeah, I did. Oh. I was getting confused because you see y and you think vertical, so sorry. Horizontal. So, going back to the last lesson. It has a horizontal asymptote, not vertical. So see what this looks like on the graph. So we have 4 different things to do. What's in red is just what the original function is. So I'm going to make this not red so we don't get confused. So let's see what we do. Okay. Here we have y equals 2 to the x minus 2 power. So what's the difference? We know the original is this. So what changed was the minus 2. So let's see. Changes to x and changes to y. Well, let's first just say the transformation. Since it's minus 2, that means right 2. So right 2. So when we're thinking of left and right, that's changes to x. And that means we're going to add 2 to x. Since nothing changed for y, we just keep y the same. So here's a table. Based on this table, we're going to change things. So these are the original points for the parent function. I have prime here because the transformation's been made. We're going to change the points. So since no changes happen to y, we'll just keep them the same. 1/2, 1, 2. And we need to add 2 to these x values. So negative 1 plus 2 is 1. 0 plus 2 is 2. 1 plus 2 is 3. So these are our new plots we need to point. Points we need to plot, sorry. So we have 1, 1/2. Alright, that would be right here. And obviously these aren't that many points. We're only given 3. I just did that for sake of time. So then we have 2, 1, 3, 2. 2, 1, 3, 2. Okay, so those are the only points we have, so we kind of just have to just do our best to draw what this would look like. So, since we didn't go up, we at least know that it's going to pretty much end up at the same place as this. Okay, and then we have this up here. And let me move. Alright, that's about what it would look like. Okay, so we can see the only change that we had was that it moved to the right 2. That's all it did. So now we have some things here that we need to fill out. And I don't think I'll do this for every single one. I'm going to move this actually on my computer real quick because that I don't want to keep flipping back and forth. So hang on a second. Might want to skip the video ahead. Yeah. Okay. Okay, so I moved it, but it's not showing up yet on the iPad, so hang on a second. Alright, there we go. So, domain, range, intercepts, increase, decrease, and behavior. Those are things we're only going to... I'll do this just for 1 and 3, how about that? So this video is not super long. I already know it's going to be pretty long, though. Sorry about that. So, domain. The domain is all real numbers. That's typically the case with the exponential function. And then range, we can see that, what does it do? It goes all the way to infinities. We at least know that. But it doesn't go all the way to negative infinity. It would just do this if it could, but then it's like, oh, asymptote, I guess I'll just do that. So it never goes to 0. And because of that, we have not a bracket, but a parenthesis. So this is what we have. X-intercepts, we have none. There's never an X-intercept unless there's a change to the moving up or down, in which it's not a reflection. So no, none. And let's see, what is our y-intercept? Well, the 3 points we were given, none of them had y or x as 0, so we actually have to plug this in to figure it out. So to do that, if x needs to be 0, we set x equal to 0, and then we can figure out what y is. So we'll do that. Y equals 2 to the x to the 0 minus 2 power, or actually I meant to do this, 0 minus 2, because we plugged in 0 for x. Then we would get this, and that would make it this, which means this. So we have 1/4. That is our or y-intercept, sorry. 0, 1/4. Where is it increasing or decreasing? It has to be one or the other with exponential functions. It's increasing, so we need to say increasing from negative infinity, because this is always in terms of x, to positive infinity, and it doesn't decrease. In behavior, as x goes to negative infinity, what does y do? Y goes to 0. It can't go to negative infinity, so it has to just go to 0 because of the asymptote. And as x goes to positive infinity, y goes to positive infinity. So they would do the same thing, but because of that asymptote, can't. Alright, so that was that one. Alright, let's do another one. So this time, we see that we have a transformation. What's different? The -3, but it's not in the power, so that means that would be our k, which means we're going to have a change up or down. Because it's negative, that means down, and 3. So down 3. That's what this graph's going to do. And changes to the x, there are none because we don't have any changes to the x, so we'll just say that. And since it's down 3, we do y minus 3. So then we have the table here. So since the x's don't change, we'll just keep these over here. And the y's, you have to do minus 3. So 1/2 minus 3 is negative 2.5, which means, well, we'll just keep it as 2.5. It's easier to graph a decimal than a fraction. Okay, then 0 minus 3, negative 3. 1 minus 3, negative 2. So there we go. That is what we have here. So negative 1, negative 2.5. Oh, wait. Also, I forgot. We have another change to y is because we have minus 3. That means that we have a new horizontal asymptote at y equals negative 3. Or what am I doing? Horizontal asymptote at y equals negative 3. So let's draw the asymptote first. So we know that our function can't go past that. Okay, and we had negative 1, negative 2.5. That would be right here. Okay, then we have 0, negative 3, 1, negative 2. 0, negative 3. Oh. That seems strange. Oh. I don't know what kind of math I did. Of course that's not right because we have a asymptote. How could it be there? 1 minus 3 is not negative 3. It's negative 2. I don't know what I was doing. And then that would be negative 1. So sorry. Let's try that again. 0, negative 2. Didn't think that sounded right. And then we have 1, negative 1. And that's all the points we found out. So we'll just try to draw that. So we know it would be along the lines of this. It's not the best drawing, but that's kind of what it would look like. And you can have arrows on that sometimes. And we're not going to do the domain range, all that for this one. Alright, this one. What changes do we have? Oh, well, we see instead of a 2, there's a 3. So that means we have a vertical stretch of 3. Of 3. And then we have plus 4 here. That means left 4. Because it's plus. Left 4. And why is it not up or down? It's because the plus 4 is by the x up there. You can tell because it's smaller print. So we have two transformations this time. Vertical stretch of 2 means that the y has to be multiplied by 3. So we'll just say 3y. And then x is, since it's minus 4, or sorry, since we had x plus 4, it needs to be x minus 4 actually, because since it's left 4. So those are two things we need to do. So the y's and x's change this time. So we'll start out with the x's. So negative 1 minus 4 is negative 5. And then we can see that would be negative 4 and then negative 3. Okay? We need to multiply these things by 3 for the y because of that stretch. So negative, or sorry, 1/2 times 3 is 1.5. 1 times 3 is 3. And 2 times 3 is 6. What do we notice here? This is, you do times 3 here, you do times 3 here. That makes sense. That's how our function works. And what else makes sense here? Well, we notice that we have, or sorry, that's not times 3 both there. That's times 2. So that's our rate that we have there. And then we have here +1, +1. Those should both be the same. That's how we know we did it right. So those are our 3 points. So we have -5. We don't have any asymptote change this time. We have -5, -1.5. -5, negative... Wait, what? Not -1.5, positive 1.5. Oh. Sorry, that happens because I have to write a certain way. Okay, -4, -3, or +3. -4, 3. And then we have -3, 6. So we can see this has a, because there's a vertical stretch, we have a more drastic change. So it changes quicker than the other original one. Okay, so we can do the domain range and things on here. So domain, still all real numbers. Range, still the same as last time. Okay, x-intercept, none, because there's an asymptote still at where the x-intercept would have to be. And we need to solve to figure out the x-intercept, or y-intercept again. So we have, okay, we need to substitute in 0, so that would make it 3 to the 4th power, which equals 81. Ugh. Good thing that's not on this graph. So because that was 81, that means that that's what our y-intercept is. It increases the whole time, so, and it doesn't decrease. So, and then the end behavior is the same as last time, so I don't need to go over that again. That's not what this unit's really about. We already talked about that before. All right, last one that we're going to do. We have a lot of transformations. Oh, crazy. So what do we have? We see first that there's a negative. That means reflection. And since it's the A that's negative, not the B, which we haven't had any B changes because, like I said, that's pre-calculus. But since that one is negative, that means we have a reflection over the x-axis. Or sorry, I was about to write y. X-axis. We have +3 here, that means left 3. And we have +5, that means up 5. So those are 3 things that we have. No vertical stretches or compressions this time. So we need to see our changes here. So we have, first we need to make our y's negative. Y is negative, then you need to add 5 to them. And you just need to subtract 3. Now, it's important that we do this in a certain order, since we have 2 y operations. Because if you didn't do it in the same order, you would get a different answers. And you need to know that we do our sign changes, which really this means multiplying by a -1. So sign changes and multiplication or division first, then our adding and subtracting. So we'll start out with the x's -3. This is what we would get. And then our y's need to be negative. Then we need to add 5 to them. So -1/2 plus 5 is 4.5. -1 plus 5 is 4. -2 plus 5 is 3. So these are our points. Let's graph them. So -4, 4.5. Oh, wait, yeah, we also have an asymptote change. Sorry. Almost forgot to say that. So we have a horizontal asymptote at y equals 5. Because we went up. So that's what we're really reflecting over, not the original thing. So that's the asymptote. It can't go. You would think it can't go above it, but since we have a reflection, we say that we have a reflection over the x-axis. It's really a reflection over the asymptote. So that's really what it is in this case. So we can't be above that asymptote. So our first point was -4, 4.5. Our next point was -3, 4. And then we have -2, 3. So now we can kind of draw that out. And then... Oh, wait. Let me see the best way to draw this. It would kind of go like this. Not that this is an asymptote, but that's just the way that the function goes. It would really go more like this. So it's still going that way. It's not really bending that way. So that's what that function would look like. And it's upside down because of that. Now, going back to the domain range, we're not going to completely fill this out, but we can see that it's decreasing because of this reflection, not increasing. And our range would change because of this, so it would be everything below 5. So that's it for this video on transformations, and I'll see you on the next one. So thanks for watching.